Hello and welcome, everybody. Thank you for joining us today for Safety Stock Strategies for Supply Chain Resilience.
Good morning or afternoon. We have talked about safety stock a couple of times in the past, but I wanted to cover it more in a little bit finer detail as we continue to find ourselves bombarded by supply chain issues, tariffs, etc. So with those many challenges, today we'd like to talk about safety stock. So I'd like to give you a quick expose about the mathematics of safety stock, and then we'll do a quick demo of our 32 soft safety stock data loader that Christian has created. As with all subjects involved with ERP, there are many terms and definitions that need to be specifically understood and applied. Here's just a short list of what you might want to investigate when you start your questioning about safety stock. Before we start a detailed explanation of safety stock, let's consider the universe in which safety stock resides, and that is the world of statistical inventory control techniques. We have started the statistical inventory control techniques with a gentleman named Ford W. Harris, who worked for Westinghouse in Pittsburgh, and he came up with the EOQ theory. Then Walter A. Stewart at Bell Labs in the 20s did a lot of work with what we'll call the independent demand aspect of statistical inventory control. And then Mr. Deming, Edward Deming, who worked in the 1950s and 60s at Minneapolis's Honeywell Regulator Company, came up with basically what we'll talk about today. These statistical techniques are based on understanding historical data patterns and the need and the ability to project those history patterns into the future. In the world of statistical inventory control, probably one of the most important differentiations we can make is to understand and apply the technical differences between dependent and independent demand. Dependent demand is demand for an item based upon a child-parent relationship and is calculated through the explosion of the bill of material in material requirements planning. This type of demand is internal, it's intermediate, it's lumpy. Little or no safety stock is required for this type of demand. We'll talk a little bit more about MRP later in the presentation, but today's primary concentration is on independent demand, and this is demand that is at the behest of the customer. This is demand tends to be external, continuous, highly unpredictable, and normally requires a forecast and necessitates the use of safety stocks. Safety stock is a term used by logisticians to describe a level of extra stock that is maintained to mitigate the risk of stockouts caused by the uncertainties of supply and demand, which we see manifest today. Safety stock is a cornerstone of supply chain resilience. It protects operations against unforeseen disruptions in demand and lead times. Strategic safety stock management helps companies maintain continuity and service levels even during unexpected market shocks, supplier delays, or demand spikes. As we said, safety stock is that extra level of inventory, and the calculation of safety stock is based upon several factors, including variability, which we'll talk about. There are two types of variability, biased and random. Safety stock helps us guard against that random kind of variability. The frequency of ordering, in other words, when you're exposed to a stockout is when demand hits for that customer independent demand. Lead time also is how long it takes you to procure or manufacture the item. And this needs to be taken into account in the calculation of safety stock. Service level is the desired level of service, usually set by management or planning, that determines how often management will tolerate being out of inventory. Service level is the ability to supply customers when they want and what they want. Carrying safety stock increases service level. Service level is calculated on the normal distribution. In manufacturing, inventory control systems calculate safety stock by taking multiple interrelated concepts into account, each tied to variability of demand, lead time, and this desired service level. The goal is to balance stock availability against carrying costs by quantifying uncertainty in both supply and demand. So let's take a look at each of these concepts involved in the process of populating and utilizing safety stock, from average demand to demand variability, average lead time variability, lead time demand, service factor, forecast accuracy, supplier reliability, criticality classifications, and economic constraints. The basic safety stock formula states that the safety stock is equal to the service level times the mean absolute deviation of demand, adjusted for the difference between the lead time interval and the forecast interval. The first and primary concept to consider when addressing the question of safety stock is demand that the manufacturing organization needs to support. Demand per period is characterized by the accuracy of the statement of demand, the ability to analyze the data, and some consideration of forecast method used to estimate that demand. It also plays with the cross-functional collaboration of the teams utilizing that statement of demand, because all of the departments in the organization are going to utilize that demand to plan and execute the operation. Organizations want and need to optimize inventory, monitor marketing change, and risk management. These demand principles guide the planning, resource allocation, and customer satisfaction. We won't spend a lot of time on various forecasting techniques, as that's a whole subject unto itself, but needless to say, it would cover discussions of quantitative and qualitative methods, time series, trend predictions, regression analysis, predictive analysis, artificial intelligence, simulation. We're planning on covering this whole subject of forecasting in the first quarter of 2026, as Denise had mentioned. Demand variability is one of the most influential components of the calculation of safety stock. Demand variability quantifies how unpredictable and inconsistent customer demand is over time. And because inventory systems must buffer against that uncertainty, the higher the variability of demand, this will directly increase the required safety stock levels. Some of the sources of demand variability include seasonality, market promotions, bulk orders, inaccurate inventories, and most often customer order frequency. Demand variability typically falls within what is called the normal distribution, sometimes referred to as the bell curve. The high point on this curve is called the average value, or the mean. The dispersion of actual sales around this mean is measured by mean absolute deviation of demand, or sigma, the standard deviation of demand. The chart shows typical percentages of demand that will fall within 1, 2, or 3 mean absolute deviations. If sigma is used for the normal curve, this means that 68.26% of the demand is expected to fall within plus or minus 1, 95% of the time plus or minus 2 segments, and 99.3, which is most, falls within plus or minus 3. We can use this estimation of demand or variation of demand in our formula of safety stock equals service level times MAD adjusted for lead time. To drive the concept of demand variance even deeper, we can consider the measurement of forecast error as a mathematical concept of what is referred to as mean absolute percentage error, where A is the actual value, F is a forecast value, and N is the number of observations. Mapping provides a clear and interpretable measure of forecast. The lower the map, the higher the accuracy. By using forecast error rather than just historical demand variability alone, we can align the safety stock policy more closely with actual performance of demand planning. Once we've come to grips with demand and demand variability, we need to consider over what period that demand or demand variation will occur in our modeling of safety stock. The next element of safety stock is referred to as lead time. There are several types of lead time: production lead time, procurement lead time, transportation inventory. Some sources mention customer lead time and total cumulative lead time. Each must be planned, documented, measured, and adjusted as required, most probably on a period basis, and not like most of us do, just set it once a quarter or once a year. It's a dynamic value that needs to be measured and planned. Lead time in manufacturing inventory control system is a key concept with regards to safety stock. Average lead time demand represents the time between placing the order for raw materials and receiving those items into inventory available for demand. Understanding and managing lead times is essential for efficient production, avoidance of stockouts, and optimum stocking levels. Lead time of demand refers to the expected quantity of inventory to be consumed or sold during a lead time period. That is the time between initiating the replenishment order and receiving the goods. It is one of the foundations of reorder point and safety stock calculation. This equation shows how lead time demand versus lead time defines the expected usage baseline, while the variability determines how much safety stock should be added. As with demand variation, lead time determination is fraught with variability. Lead time variability is the planned lead time as stated in your inventory planning system, for we in QAD, that's 1.4.1 or 1.4.7, compared to the actual lead time recognized by the actual receiving of units and then measuring that differentiation. This requires that you measure the actual lead time as it occurs for each element of lead time. Here we can see the safety stock formula, where both demand and lead time might vary. Because there's typically a difference between the lead time in an item and the forecast interval, that is, you forecast on a monthly basis, but your lead time is some fraction or value not equal to a month, there needs to be a method to adjust the safety stock calculation for this lead time difference. That difference between the forecast interval and the lead time. As long as the distribution of demand is normal, there's an adjustment factor that can be derived from the relationship between the forecast interval and this replenishment lead time. Here we see a short example of the measurement of lead time variability. First, you gather the information, then you complete or compute the average lead time by simply adding the lead time squares and dividing by the number of observations. This particular example shows that the lead time here typically varies by plus or minus 1.4 days around that mean. Adjusting the safety stock calculation by taking into account the differences between lead time that is different from the forecast interval is critical to this safety stock calculation. Here is the normal distribution graph illustrating how safety stock is adjusted when lead time intervals different from forecast intervals. the forecast overlay of demand distribution for a single forecast interval and extended over the lead time. The safety stock region is marked to show managing variability across that entire lead time. Service factor is a relationship between a safety stock calculation. It is a multiplier, often referred to as the Z-score, that reflects management's desired probability of not running out of inventory during lead time. As such, the service factor represents the organization's targeted service level, such as aiming to meet customer demand without stockouts 95% of the time or 98% of the time. The higher the service factor results in more safety stock, ensuring higher availability and lower risk of stockouts, but there is also an increased inventory cost. This concept allows supply chain organizations to mathematically link inventory policy to customer service objectives, directly balancing investment with acceptable risk of shortage. Statistical inventory control systems assume the normal distribution. That is the mean absolute deviation. Therefore, mean absolute deviation can be used to determine the amount of buffer inventory safety stock required for a given level of customer service over time. There's no reason to carry safety stock to provide a 50% because the demand is just as likely to be less than forecast or greater than forecast, and safety stock is only needed to compensate for demand which is greater than forecast. Since it is impossible to carry enough safety stock to ensure 100% service level, because there's always a slight chance that demand will occur and will be greater than the safety stock. Here we see that an 80% service level might require an annual cost of $286, but to increase that service level to 99%, you would have an almost 93% more inventory to cover that 99% coverage. Supplier reliability has always been a direct and significant impact on safety stock requirements. The higher the reliability of the supplier, the lower manufacturing has to maintain inventory stock level to ensure delivery to customers. This is because the risk of delays or disruptions in the supply is reduced. Conversely, unreliable suppliers who deliver late, short, or inconsistency necessitate higher safety stocks to buffer against uncertainty and demand. Through the example we see here, with an average daily demand of 100 units, a Z-core of 98%, which is a service factor of 2.5, the standard deviation for a 2-day, a high reliability, we can see that the safety stock is 410 units. But if we allow that supplier or measure it for a higher unreliability to say 5 days, you can see that the safety stock could raise almost double to 1,025. QAD has several tools to assist in this measurement, including supplier management, supplier performance in the EE versions, QAD's EQMS, and the supplier portal. ABC, or criticality classification categorizations, can play a significant role in assisting in the determination of safety stocks. By prioritizing and classifying inventory based on value, usage, or impact on production and business outcomes, organizations can control the application, management of stock levels, replenishments, and risk mitigation for the calculation of safety across their inventory populations. This prioritization allows organizations to tailor safety stock levels according to importance and risk associated with each inventory item. Here we see a few of the various item master and data records that have been or can be used to assist in safety stock calculations. There are also several local and global economic conditions which can contribute to the calculation of requirements for safety stocks in manufacturing environments, such as budgetary limitations, cost of capital, inventory carrying cost, tariffs, which we've seen a lot of in late, international supply disruptions, if we all remember the Suez Canal fiasco, global demand shocks, current fluctuations in trade policy, supplier risks, transportation system reliability, and macroeconomic instability. These shape the environment for safety stock in the inventory control system. Many of these are hard to quantify or compute with mathematical equations, but that is becoming easier with such tools as ChatGPT, Claude, Perplexity, etc. Organizations must balance the risk of safety stockouts, lost sales, and production stoppages against these financial and global considerations when making decisions central to safety stock calculations. As many of us have discovered, safety stock is a somewhat problematic value in QED's ERP code. The process of calculating safety stock and utilization provides many challenges for users of QADs, specifically since there is nothing in QAD that directly assists in the calculation of a safety stock value. Normally, a planner must run inventory reports, access existing inventory levels, consider various types of demand, consider lead time variability, analyze usage trends, account for end-of-life parts and obsolescence, then consolidate data, determine a new safety stock value, and probably the most painful is input the safety stock value into 1.4.1, 1.4.7, or 1.4.17. To that end, Christian has been very effective in creating a 32-soft data loader application that makes both the calculation of safety stock values and the update of those values simple, easy, consistent, and time saving to ensure accuracy of those values in the calculation of either a reorder point or material requirements planning. Using the 32-soft safety stock loader simply starts with executing the loader as a familiar Excel function. Then enabling the contents of the spreadsheet. Listener, Tomcat, Excel may need some assistance with setup, but basically you're executing an Excel spreadsheet. Once executed, the 32-soft loader has several areas of concern. The first is the selection criteria. Here we see buyer, supplier, site, promo group. These are modifiable according to your categorization codes. The action button area allows for download, manipulation, and control of the process, and includes download, upload, comments, setup, clear, find errors, help, switch domains. And these are also modifiable if needed. Next, from the setup button, one can select the database to which you might want to connect by entering a user ID, password, and domain, thus conforming with QAD's internal security functions. The list of columns retrieved from the selected QAD database in the loader include monthly usage data, total and average usage data, cost data, reorder point data, and at the first execution, you will be required to enter your QAD user ID and password and domain you wish to access, thus again conforming to the QAD security system. Based on your selection criteria, the system will download into the 32-soft safety stock loader the current column values for each item. Based on your definition of your categorization codes and your determination of which transactions you want to select for the suggested safety stock level, which again can be modified to your specifications, the planner inputs the new safety stock level or other definable elements. And here's a list of the possible transaction codes that you could access for that calculation. Once the new safety stock value is determined, either from suggestion or other process, the upload button loads the values to the selected database. The loader indicates all data was loaded successfully, or you can use the find error button to identify which records need attention and or review. As an additional function, the 32-soft loader provides a column for remarks or comment elements, which can be used to record a reason for the safety stock change. This can be either a mandatory field or an optional field. The loader is equipped with a function to check all previous comments or reasons for change. The comment button provides a report of all the previous comments used by user ID, date, and time of change. As we see, the safety stock loader control is complex, but the vital element of your planning process and your ability to control your manufacturing inventory environment. Benefits: you have real-time information, ease of use through an Excel formatted data, easy upload and reporting, up-to-date planning information. You can load hundreds of records in minutes. It limits variations in safety stock management approaches among planners. Increased cash flow and increased satisfaction can be derived from this loader process. In addition to the mathematical function of safety stock calculations, manufacturers should deploy additional tactics to build resilient supply chains. These might include supplier diversification, inventory optimization, flexible manufacturing, reshoring versus nearshoring, scenario planning, just in case, tariff engineering and free trade zone use, and upgraded visibility and communications, including increased use of artificial intelligence. Safety stock in MRP, we've seen the function of calculating safety stock plays most immediately in the order process. Once you discover that you've consumed your safety stock, the next is order more. The two primary means of ordering in ERP are firstly reorder point or through material requirements planning. Enter the safety stock as a quantity of this item to be made into inventory as a protection against the fluctuation in inventory demand or supply. MRP considers safety stock as a requirement and schedules planned orders to cover that amount. When the projected quantity on hand falls below safety stock, MRP plans an order. The reorder report in QAD can be set to trigger that planning function. Lead time in material requirements planning is the amount of time it requires to obtain, manufacture, receive goods after placing the order, and is critical in scheduling and planning. MRP uses a defined lead time in 1.4.1 or 1.4.7 to determine when orders for materials or components should be released so that the items are available when needed to meet the production schedule. In addition to safety stock, which is a quantity of an item to be obtained, material requirements planning also utilizes a safety lead time. Safety lead time is a hedge against added between the actual need date and the planned receipt date. It causes both the planned order receipt and the receipt to be an actual date calculated in the MRP process. This function is to schedule the orders to be released X many days earlier than normal calculation. With the integration of AI and machine learning for forecasting demand and supply risk aversion, real-time tools are aiding control over demand variations through the adoption of cloud-based inventory platforms, the use of digital twins, Companies are deploying multiple tier inventory strategies to diversify sourcing and safety stock calculations regionally or for what are termed corridors of supply. Automation frees professionals from manual calculations, making inventory management more strategic and real-time. The ideal environment for effective inventory management tools, the optimal frequency for recalculating safety stock depends on product volatility and business impact. This can range from weekly for high volume or fast moving items to quarterly or even semi-annual for stable. So what have we talked about today? We've talked about subjects regarding safety stock from lead time, variation, demand, independent demand, average demand, variability, lead time, service, ABC classifications, economic constraints, normal distributions, standard deviations, and service factors. In any ERP, managing all the possible elements that relate to safety stock can be time-consuming and tricky. 32Soft's myriad of data loaders make managing details in QAD fast, easy, and error-free. Download real-time customer data, massively update, revise data to QAD, validate your data accuracy, correct flagged errors, and increase your productivity. As you can see, safety stock addresses basically everything you do in QAD. Since we all use QAD ERP system, the more quickly you can get data in and out of QAD, the more effective is going to be your planning and execution. 32Soft data loaders bring logic, accuracy, and consistency to your ERP process. You want to understand, as we mentioned, the terms and the functionality and the concepts behind safety stock. Build your safety stock acumen. There are online resources, there are books, there are courses that you can take, Apex and other. You can use the QAD user groups, West Coast user group, Midwest user group, Southeast user group. As a matter of fact, just today is the first day of the Champions of Manufacturing in Dallas, Texas for QAD and Red Zone. It'll be interesting to see what comes out of that meeting. You can gain a lot of information on the QAD forums. The QAD knowledge base is my go-to after F1. And as I mentioned, you really need to understand ChatGPT, Gemini, Perplexity, Claude, all of the AI tools that are quickly becoming available for safety stock and risk aversion. There's the QAD document library, everything you ever want to know about QAD if you look hard enough. There's the Learning Center, and here is a list in the 32Soft website that we created of all the URL sites, documents, records that we used for this presentation. Just click the URL link on the 32 website, and you're brought to a list of various subjects regarding safety stock that can help you better understand safety stock in your environment. As always, good to learn how to use social media and artificial intelligence to search for information in this age of Aquarius, from Gemini to hashtags to Perplexity. Call to action. Safety stock is the primary and probably most effective way to guard against uncertainty in your manufacturing inventory control application. Take control of supply chain uncertainty. Analyze each safety stock element, including demand, lead time, and variability. Calculate your new safety stock value and load that value into your QAD ERP system to proactively shield your operations against the disruptive production surprises and realize the full benefits of a robust inventory control manufacturing. We hope you've enjoyed this quick walkthrough through some of the concepts involved with safety stock. and how you might use them to take advantage of all of the opportunities in your organization. Your ability to utilize, execute, and control complexity of manufacturing in ERP is critical to your success in today's competitive environment. Please contact Denise, myself, or Alex if you have any questions regarding safety stock. Thank you so much.